Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I want to do is just kind of go over the landscape of development in 2021, like what are the different languages, what are the different frameworks, what are they for. This isn't going to necessarily be targeted towards sort of what are the most popular frameworks or what's going to get you a particular type of job, just sort of like what's out there and why does it matter. And a little guidance on sort of like if you're new to this space and you want to be a developer, sort of where do you start? And I mean, honestly, where do you start? Let's make that our next slide. So we're going to build this presentation together because I figured that would be a good way to have a more sort of lively, energetic conversation. Instead of having like a bunch of preset slides, you're engaging in this with me. Okay, so let's make a new slide. Where to start? Okay, where should we start? Where to start? Okay, bottom line is this. Once upon a time, you had different sort of paradigms. You would have desktop applications, you have mobile applications, and you have web applications. And basically, the idea is that desktop applications were designed to work in a particular operating system: Windows, Mac, the Java virtual machine, Linux. And you would program in a language that's designed for that environment. Same thing with mobile. You would use like Swift for Apple apps or Kotlin for Android apps. But nowadays everything is so integrated with the internet, and you would also have apps that were designed for the browser, that everything kind of just works through the internet. So everything is sort of web connected. So understanding web technologies oftentimes is now really where you want your core as you expand into the world of development, because at the end everything is going to end up connecting back to the web, even if it's just for the fact that you're going to be using things like GitHub and a lot of remote type working skills that rely on web. So in that case, really the first place to start is just learning the basics. HTML, hypertext markup language. Okay, so this is a markup language, which means it's not like a traditional programming language that allows you to set programming language, to set directions on how things happen in what order. What it does, it allows you to create a architecture for where things should be relative to each other. So it's more like, this is how my information should be displayed. Okay, very important, because nowadays you can build your user interfaces even for desktop and mobile apps using HTML and CSS, cascading style sheets. Okay, and essentially, while HTML says like this is where things are relative to each other, CSS gives a much more aesthetic meaning to that. Like is the font bold? What color is the font? Where is it absolutely positioned on the screen? These kind of things are done in the CSS. So HTML is like, okay, what? CSS is, how does it look like? But nowadays websites are much more dynamic and much more interactive, and that interactivity comes from our first official traditional programming language, JavaScript. Okay, JavaScript. And JavaScript is pretty much sort of the biggest language these days. It started out as this sort of podunk language back in the 90s. That was, I think it was like 1996. It was made in 10 days, and it was really just so you can like do pop-ups in the browser, on Netscape Navigator, and it's just evolved into sort of one of the most powerful and far-reaching languages on the planet. So it should be the first language you learn. It's not a hard language to learn, and it's a very powerful, far-reaching language that even if you work in other languages, you'll probably end up having JavaScript show up in your code, because you're inevitably going to have to work with client-side web code, which is HTML, CSS, and JavaScript. Okay, so think of this as basically this just does normal programming logic, loops, if statements, all that fun stuff. So JavaScript. So basically the first thing you want to do is really kind of get these three going. Start learning sort of just how to build your basic front-end website, maybe a basic browser game, pulling data from another API. So these are sort of some initial goals. Okay, so basically basic sites, again, browser game, make a little browser game, website based on third-party API. Like these are going to be the initial projects that are going to really build your skills with these things. So that's where you're going to want to start. Okay, but where do you expand from there? Because this is all what's referred to as front-end code. It's code that's rendered by the browser. Okay, and then you're going to want to expand from there. Okay, so new slide. Now, once you get past the front end doesn't hold information. I mean, you have this thing called local storage in the browser, but as far as like having a central database of records and information, that has to be done somewhere else on a server, which is referred, and this type of development is referred to as a backend development. So you're no longer running code that's running on the browser in the user's computer. You're now running the code that runs on the server that hosts the database, that connects to the database, that interacts and sends information to the front end. And this can be done in literally any language. Okay. So here's the first time we're going to sit there and really talk about the different types of languages. Okay. Now there's what's referred to as a higher level language. A higher level language is a language that does a lot for you. So it's a much more pleasant development experience. So like JavaScript is a high level language. You don't have to worry about things like managing memory. It does something called garbage cleanup for you, where if you just don't use a variable anymore, it just gets rid of it from the memory. The downside of that is, well, that's convenient. It makes your life a lot easier. Then you have this process that's running with your code, which can, in large scales, slow it down a little bit. So the languages that kind of have this sort of leaning towards convenience over absolute optimal performance are languages like JavaScript, which you can also use on the back end using a system called Node.js, which allows you to run JavaScript outside of the browser. So that's what Node.js does. It allows you to just run JavaScript on its own without the help of HTML and CSS in a browser. Now you can actually use it to create servers, to create scripts, to automate things, anything you could do with any other scripting language like Python, Ruby, okay? Anything you can do with those languages, okay, you can do with JavaScript. Okay, so it puts it in sort of that category. Okay, so those are like the higher level languages. These are going to be the easiest languages to learn. And because of that, a lot of people use them. So they're very filled with jobs, which is again benefits. So they're easier to learn. There's going to be more jobs in them because people use them to do a lot of sort of basically to the point where you start really seeing performance issues. You're talking about like really large scales, and it's at that point you start thinking about like. And then actually while we're here, before I even go on to the lower level languages, what's going to happen is that when you learn a new language, especially if you're working in the back end, making the servers, the databases, all that stuff, you're going to want to learn a back end framework. It's basically a set of tools that's going to make creating that server a lot easier. And in the JavaScript world, the main ones are going to be like Express, Nest.js, or Nest.js, Koa, FullTS. JavaScript has a lot of them. FullTS, Fastify, it goes on and on. Okay, in Python, the main ones are going to be Flask and Django. There's other ones too, but those are sort of the main two. And then in Ruby, it's going to be Sinatra and Ruby on Rails. Okay, and then generally these come in two flavors. There's the minimalist, which is going to be more like Sinatra, Flask, Express, Koa, where basically they just give you the basic features to start building your server. And then like if you want authentication, like so you can verify who users are, you have to bring that in. If you want like sessions, so you can have like keep track of who is logged in, you can bring that in. You know, all this extra stuff you bring in and you build on top of your core server. The idea is, you know, to allow you to just, if you only need something really quick and really small, you can build that. Okay, so that's Flask, Sinatra, and Koa, and Express. Django, Rails, Nest.js, and FullTS it was referred to as a batteries included framework. They already kind of brought all that extra stuff in, as far as like connecting your database with migrations, authentication, basically just spinning up your whole project through a few commands. They kind of have built in there for you to save you time. Always the downside is you have all this extra bloat, and there's a lot more learning because you have to kind of learn how everything connects to each other before you can start really taking advantage of the speed that it provides you. So they're kind of harder to learn, but once you learn them, you'll find that building a web app is like super fast because the framework is doing a lot of the work. While things like Express, Flask, and Sinatra are really easy to learn. Like, they're not hard at all. But every time you make a new application, you're kind of, unless you build your own boilerplates or whatnot, you're kind of rebuilding a lot of things over and over again, which is fine. It makes you a better programmer, but it is more time intensive. But you have more control over exactly how things work. So there's always a trade-off depending on the project. Like, does your project really need the extra customizability? Or is this going to just be a basic, like, hey, let's go get a list of dogs? Then maybe you want to use a batteries included framework that'll just quickly spin up what's called CRUD, the ability to create, read, update, delete data pretty quickly. Okay, so those are the frameworks for these higher level languages. Now let's talk about lower level languages. These are languages that don't do as much what's called garbage cleanup. Okay, so some of the memory management and memory considerations are kind of up to you in how you program. So this means they are harder languages to program in. So I would recommend learning these first, or at least one of these first, and getting pretty good at it before you take on one of these languages. Because these languages are going to be much more challenging. Okay? Yeah, they're just going to be much more challenging because you have to do a lot more typing. Okay? So the epitome of lower level languages is, the ones that have been around forever, C and C++. You generally are probably not doing back-end servers in C and C++ unless you really, really need extra speed. Fun story, Facebook was originally created in PHP, and actually on that note, let me add PHP to this list right here. PHP is a pretty solid language, and a lot of jobs in PHP, because PHP is the language that created WordPress, and WordPress is over half the internet. So there's a lot of money just in the WordSpace place alone, in creating like plugins and customizing WordPress. But there's also, basically, PHP came out with a framework that's very similar to like Ruby on Rails and Django, and all these sort of batteries included frameworks called Laravel. And Laravel has really kind of invigorated new life in PHP development. And PHP was really built for the web. So PHP, when you're doing web stuff, has a really sort of very nice feel, because you can just literally just whip up a PHP file and it just works. Okay, there's not as much sort of setup. So PHP is a pretty cool language. But what happened was with Facebook, it was originally created in PHP, but they needed to kind of get that extra speed of using a lower level language. So what they literally had to do was create a C++ transpiler. So it actually, they still write their code in PHP, but the transpiler takes the PHP code, translates it to C++, and then their server is actually in C++, which is an interesting way of doing things. But it was a interesting story. There's a lot of interesting stories when it comes to Facebook and development. Okay, so you have C++. Okay, let's see here. Let's get over here. But in latter days, there's other languages, like other languages that came up to try to compete with C++ are like Java. Java's still one of the hugest languages on the planet. But the thing with like C++ and Java, if you're like someone looking for a job, is that these languages have been around for like 20, 30 years. So there are developers with 20, 30 years of experience in C++ and Java. So they are much more competitive languages to get a job in, because there are long-time, super experienced, very advanced developers in those languages. Now, the trade-off is, so basically there's a lot more jobs in those languages, but they're more competitive. The trade-off is with newer languages, there isn't as many jobs, but they're less competitive, because there isn't somebody, like for example, when we're taking a look at languages like Rust, okay, which is from the people over there at Mozilla Firefox, or Go, or Raku, which we'll come back to Raku for a second, because that's another interesting story. When it comes to these languages, they haven't been around that long. No one can say I mean, you'll see job ads that say, hey, we want someone with 5 years of experience in Rust, but that's impossible. The language hasn't been around that long. Again, job ads oftentimes don't necessarily know what they're asking for. But these are lower level languages, okay, that were built to kind of provide the speed of like a Java and C++, but but with a much more pleasant development experience. Okay, and they both have interesting ideas baked into them. I would say Go probably is the easier one to learn. Rust has probably a slight speed advantage because it has some extra steps you have to do regarding memory. But they're both pretty cool languages, and if once you've kind of gotten pretty comfortable with a higher level language, one of these is actually probably a pretty good way to go if you're a newer developer. And Raku, do I consider that a lower level language? That one I'm still debating on. Now, let me tell you what Raku is. Like, technically Raku, okay, going back to higher level languages. So let me just add another language over here. Okay, Perl. Perl was one of the earlier web languages, and right now it's on Perl 5, and then it's going to be Perl 7. Okay, so where's Perl 6? Well, Perl 6 was so different that they had to rename it, because it basically was a different language, so it's called Raku. So I would probably put that as a higher level language, because it's really kind of meant for, it's not really meant for systems like that. Like, it doesn't have memory management in it. It is a pretty complicated language, not an easy one to learn. So whether it's Raku and Perl, they're going to kind of work the same way, because at the end of the day, they were from the same cloth. But a lot of this basic syntax and basic keywords you use are different. So these have kind of splintered off into two different languages. So Raku is trying to, bring back, and then right now they're starting to work on Perl 7. So, always there's the hope among Perl developers that one day Perl makes a comeback. Which, again, it's a fine language that's been updated. It's just, again, it is a little bit more complicated than, let's say, JavaScript or PHP. Other lower level languages, let's see here. Now, let's say you really like Python, and you want that kind of experience, but you want a lower level language. There's Nim. Okay? And what if you like Ruby, and you really like Ruby syntax, but you want kind of that lower level speed of a lower level language? Then there's Crystal. Okay, so that's where Nim and Crystal come in. They're languages that take the syntax of popular higher level languages and create a sort of a lower level compiled version, so you can get some more speed. So that way you can program in the way that you're used to, whether it's Ruby or Python, but instead of having it be interpreted, because most of these languages, these higher level languages, they're interpreted, which means that when you run the script, when you run the code, that's when you actually translate it. So the computer's doing two things. It's running the code and translating the code at the same time, not quite as fast. Compiled languages like these, what happens is that the code gets compiled first. Okay, so it gets translated into machine code, and then you separately run it after the fact, which also means more speed, because you're not doing two things at the same time. So these are compiled sort of lower level languages. Yeah. Okay, so all of these can be used for web development, and there's other languages too that can be used for web development. The list never ends. But this is a pretty good initial list. We'll keep going on. Okay. Now let's make another slide. So let's see here. You've learned a little bit about the front end, HTML, CSS, and JavaScript. Then you went to the back end and maybe learned one or two languages there and learned their frameworks. And let me list some of the frameworks for some of these lower level languages. I forget the names of some of the other ones, but I know like Go has like Mux and Buffalo. Java, the big name in Java, Spring. I haven't played as much with like Nim, Crystal, Rust, and C++ as far as backend servers go, to know sort of any particular frameworks there. Feel free to list them in the comments if you're watching this, if you sort of work in those spaces. But nowadays, mobile development would be sort of the next frontier. Okay. Now, in mobile development, typically if you're doing sort of an Apple iPhone, Apple iOS apps, okay, the languages you'd want to learn was originally Objective-C. That was the language that was being made in, but it was a terse, verbose language. Okay. So what people use nowadays is what's called Swift. Okay, so that would be the language to learn if you want to do specifically iOS apps. Okay, if you were doing Android apps, they were primarily developed in Java originally, but nowadays everyone's kind of moved over to Kotlin. Okay, and these languages are think of these sort of like as like the shift from going from like C++ over to, let's say, Ruby or Python, as far as difference in difficulty. Okay, but the problem is, if you're doing Kotlin, you're only doing Android apps, and if you're doing Swift, you're only doing iOS apps. which has its benefits in the sense that you get to access the newest features of the phone right away. So if you're building a cutting edge app that's using cutting edge features of the phone, then you're probably going to want to build native apps in those native languages. But if you're just building an app for pretty much anything else, a basic game, a restaurant app, a fan club app, anything like that, then there's other technologies. One of the most popular being Dart, which is another programming language, which could also be used for web, but it's most popular to be combined with what's called the Flutter compiler. What it takes is it takes Dart code and turns it into an iPhone and Android app. So that way you can actually write once and then really kind of have an Android and iPhone app right out of the box. Another popular approach to this is React Native, Ionic, and NativeScript. These three frameworks all work in JavaScript. So these allow you to do the same thing in JavaScript. You write JavaScript code, you can then send it over to iPhone, Android. Pretty cool. Okay, and then there's a version of this kind of for Ruby, but I forget what it's called. And then there's Xamarin. Now Xamarin is for .NET. Okay, we haven't talked about .NET yet, but .NET is technically three languages: C#, okay, which is their most popular language; F#, less so; VB.NET, which is kind of, I don't know if that's really all that used as much anymore. That's basically the modern version of Visual Basic, which was a popular language in the 90s. But this is basically Microsoft. And Xamarin is the framework for their .NET framework to build mobile apps. So these are all different ways for you to kind of enter the mobile development space. And also there is Python. Python has a framework called Kivy that does the same thing. And I'm trying to remember what the Ruby one is. Let me just Google that real quick. Ruby mobile development. Ruby Motion, that's it. Okay, so Ruby Motion. So if you want to do it in Ruby, then there's Ruby Motion. And actually, I think this is just Kivy. Cool. So you want to do mobile development, you have these options. So again, you're noticing JavaScript is everywhere. Okay, you can do everything in JavaScript, and that's cool. And then all these, yeah, I'll just kind of stop there for a moment. Okay. So basically, we're talking about web development, front end and back end. We talked about other cool stuff. Now let's see here. New slide. Let's talk about desktop development. There isn't as much of a need for desktop apps as there used to be, because now you guys can do everything in the browser these days, because browsers have become that powerful. But there still is a desire for desktop apps. So there's things like Electron, okay, which allows you to actually use JavaScript to make desktop apps. So things like Postman, if you're a web developer, is built, or GraphQL Playground. These are apps that are really just web apps contained in a desktop app. Okay. Okay, so Electron, JavaScript. In Python, there's a library called PyQt. But there are libraries for creating desktop like GUIs in all the different languages. And nowadays, even like just command line scripts are becoming pretty popular again as well. And in most of these languages, you can create command line scripts where you just kind of go into terminal, you type in a command, and everything kind of happens in terminal in your command prompt instead of sort of a visual graphical interface. Okay, so PyQt is Python, and Qt is a library that you can find in other languages as well. I think you can find it in most other languages. So let's see here. Okay, moving on. Other languages. Let's talk about other languages that I haven't mentioned yet. Okay. First off, let's talk about .NET. Okay, so again, .NET does everything. You can do desktop, you can do mobile, you can do web applications in .NET. And the .NET environment allows you to use multiple languages. So you could be doing code in C#. C# is a higher level language, so it's somewhere between JavaScript and Java. Okay, I think it's a little bit more higher level than Java, but a little bit more lower level than JavaScript. Okay, C# is huge in gaming. Okay, so if you're working with like Unreal Engine, Unity Engine, these game engines, C# is sort of like the language of choice in the gaming world. So that's one place where like that language sort of dominates. But you can use C#, F#, and VB.NET. These are the three main languages of the .NET framework. So you could actually have parts of your code in all three languages, and they all work together because it's built to kind of build that same patterns, and then provide the same tools regardless of which of these languages you're using within that environment, that .NET framework. So that's pretty cool. Okay, so that's what .NET is. Now, the things to think about with like Java and .NET is that these tend to be frameworks that tend to exist heavily at larger enterprise level companies. Why? Because generally giant companies, multinational corporations, these kind of companies don't like to take risks. So they want to go with the framework with the biggest name recognition, and that's going to be like Java, Microsoft, so that's .NET. These kind of names are going to be very recognizable to them, and they know they're going to be around 5 years from now, so they're going to want to work with them. So the biggest companies, they're looking generally for Java and .NET developers. But at the same time, they're also going to be the pickiest. They're going to be the ones who really do care, like, do you have that computer science degree? Do you have like the 5 years of experience? Because again, they don't take risks. So if you're that entry-level programmer who's coming in through a boot camp, like myself, when I started, or you're coming in through self-teaching, which is also a possible route, chances are you're going to want to look at sort of what the medium to small startup level companies are doing, and they're probably going to be somewhere more in like the Python, Ruby, JavaScript, PHP side. Okay, that's kind of where those jobs are going to exist. Okay, just to keep that in mind. Still worth learning Java and .NET, and again, they are harder languages, so you probably want to learn one of those lower level languages first before you kind of graduate to those other languages. But just be aware of that dynamic when you're thinking about, like, it's not just where the jobs are, but it's like the dynamics of like who's hiring and sort of like how are they going to look for people. Then there's like a lot of niche things that I haven't mentioned yet, such as OCaml. OCaml is a functional programming language. My experience with OCaml has been in JavaScript. In the Node environment, there's an implementation of OCaml which you can use to essentially write JavaScript. It transposes JavaScript, and then they took OCaml and they made an easier version of it that's kind of more like JavaScript called ReasonML. And again, the benefit of this is just it allows you to use very strict functional programming, which is a style of programming, to create web applications, if that's what you want to do. Okay. On that note, Microsoft came up with TypeScript, which is just a superset of JavaScript. So if you know JavaScript, you know TypeScript, because TypeScript is just JavaScript plus some stuff. Okay. And TypeScript was really made to allow JavaScript to be used at enterprise levels. It has certain features that JavaScript doesn't have natively, like typing, that makes it easier for a bigger company to be able to use JavaScript, or in this case TypeScript, to do web applications using TypeScript in a way that allows them to kind of manage quality control, easier error finding, stuff like that. I think it's very worthwhile to learn, especially if you're already learning with JavaScript. Spending like the extra half a day to learn the extra bits that are TypeScript isn't too big a deal. Okay. TypeScript, other fun languages to mention. I haven't mentioned. There's a bunch of other functional languages that are used in web. Elixir is another functional language. When I say functional language, just expect that it's going to be very different than most of these other languages I mentioned so far. Okay, functional languages tend to just work differently. They're going to be a lot harder to learn because they're not. It's not like you go from, let's say you went from like Python to Go. A lot of the ideas and functionality is the same, even though the syntax is very different. A lot of times, a lot of the paradigms in, like, let's say OCaml, Elixir, Elm, Clojure are very different. It does require you to start to be open to thinking differently about how you think about your code. Elm is interesting because Elm is purely for building front-end UIs. It's actually pretty cool. I would recommend watching a video tour on it. The design of it's actually pretty neat, but it's really just for that one implementation. You create your front-end UI, and then it transpiles it to HTML, CSS, and JavaScript. And then you can create sort of the idea is to create applications that just don't break because the functional paradigm forces you to kind of think in a way that you're not going to run into sort of runtime problems. Like if it compiles, it works, is sort of their claim. And from what I hear from other developers, it actually does that. But these are, again, very niche. There may be jobs in them, but I wouldn't say there's like a lot. Okay, but again, there's probably not a lot of developers either. I do know, I think with Elm, there's companies out there that literally will hire you if you don't know Elm, because there's so few people that know Elm. They'll hire you and train you on the job, and they're actually very happy with that because, so, there's opportunities everywhere. Don't close your door to anything. I'm trying to think if there's any other languages that I am missing. I think I've gotten most of them. Oh, yeah, I want to make sure I mention Ballerina. Ballerina is very cool. Ballerina is a language, this is very new, very cutting edge, but it's a language that's built for sort of modern web cloud computing dynamics. So it's built to be building Docker. It has like built-in features for like Docker images, setting up HTTP servers, and having multi-threaded web processes. It's very cool. It's actually what I've been spending a lot of time learning lately. Who knows what future it has, but it's very cool. Okay, yeah, okay, cool. So I think that's a pretty good pattern, so you can see sort of all the main languages. I mean, literally just learning all these languages would take you the rest of your life, so that's all good. Not necessarily learning them, but mastering them. Or actually probably it would take multiple lifetimes to master all of them. And the thing is that within each language, there are several libraries or frameworks that are pivotal. So I'm going to focus more on like website because that's what I know. So let's talk about front-end web frameworks, front-end UI frameworks, because this is where a lot of the front-end jobs are. Biggest one is React. Okay, and if you learn React, there's a lot of companion libraries you're going to want to learn too. Redux, React Router. Okay, and each of these libraries in this slide are built for helping you build sort of the front end of your website. Like how do you build the user interface? Okay, not the back end. That's what the back end frameworks were for. How do you build your server? This is how you build the part the user interacts with. React Router, Next.js, Gatsby.js. These are some of the main sort of pieces inside the React ecosystem. Then there's Angular. Angular is kind of pretty all-inclusive. It kind of builds everything inside of it, which makes it probably the hardest to learn of all of these because there's just so much going on in there. But the idea is that it's an all-inclusive package. So generally, you need a router. It's built in Angular. State management. I think even server-side rendering is it's all in there. You just gotta learn the framework. So you just have to learn Angular and all the bits and pieces of it. This is why Angular tends to be very popular at bigger companies, because Angular has a way to do everything, and bigger companies always like there to be less unpredictability, because again they don't like to take risks. So they like Angular because one Angular developer can easily be swapped out with another Angular developer, because there's just sort of a Angular way to do things. Well, with React, you can kind of do things in a lot of different ways. So you might find two teams working with React doing things in two completely different ways. Let me just correct the spelling here. Okay. But React is very powerful in what it does and allows you to create some pretty interesting logic. I am a big fan. Then there's Vue, which has been growing on me quite a bit. And what's interesting is that React was created by Facebook. Angular was created by Google. So of course there are going to be big names in this space. But Vue is the only one that's not backed by a big company. It was a guy, Evan You, who was a former Google developer. This is why a lot of Vue syntax is very similar to sort of older Angular-like syntax, but it finds a nice balance between being sort of easy to use, but giving you a lot of tools to use. So somewhere in between React and Angular, Vue's kind of find a nice sweet spot and has been able to really grow and have its own chunk of the market between developers who just really enjoy the experience. And I must say, now that I've been doing more Vue lately, I do really enjoy sort of the Vue workflow. It is very pleasant. I'm not having to configure stuff as painfully as Angular, but thinking through my data and my data logic isn't necessarily as painful as thinking through sort of state management in React sometimes. So it is really kind of pleasant. And then there's Svelte. Svelte took the Vue experience and made that even easier. So, basically what you do is you just use their Svelte syntax, which is a lot like Vue in format, just with some slight differences. But then it gets compiled into really, really fast code. You're not shipping, like with Vue, Angular, React, you're shipping the React, Angular, Vue library with your website, which makes your website a little bit bigger. Svelte gets compiled, so all you have left at the end is just what you used. So it loads pretty fast. The other big thing is web components. Web components are not huge yet because some browsers are still catching up with compatibility, but web components are sort of like a new feature in browsers that allows you to do a lot of the things you can do in these frameworks, but just in JavaScript. You don't need a separate library. And there are libraries that help you work with web components, such as Stencil.js, okay, Lit HTML, okay, which is from Google, which allows you to work with web components. There is my libraries. I have a couple libraries in this space: Merced UI, Amponent, and there's one more I want to think of. Component Zoo. Okay, and then Salesforce has their framework because they use like web components in their space. Lightning components. Okay, and actually I think the specific web component one's called Lit Element. Lit Element is Google's thing. Lit HTML is too, but it's more like a weird like string literal thing. Okay, so the web component thing is its own world that's been building up. A lot of people are creating libraries in this space because in the future, why have the extra bulk of a library? And the cool thing is, when you build web components, you could use them in Svelte, Vue, Angular, React, because they're just native JavaScript. So you just bring them in and you can use these bonus sort of components in there. So you could build something and it works no matter what framework you're using, which is really cool. So that's some cool stuff in that space. Okay, we're kind of going long, so I'm going to try to wrap this up with just some other trends. Okay, GraphQL. GraphQL sort of... GraphQL is pretty cool. It's just another way to build APIs. Again, APIs are how you pull data from like a server for your front end. And there's RESTful APIs, which has been the standard up till now, where you have like different API endpoints and you just go to different URLs, they give you different data. GraphQL says you use one URL and then you send like a little recipe for what you want to get back. They're both pretty cool. They're just different styles of building an API. What matters is that you build a working API. Okay, static site generators. Okay, static site generators, which are becoming popular because a lot of websites don't need to be updating themselves constantly. Okay, maybe the information only changes periodically. Let's say like a blog. Okay, you don't have constantly, you post a blog post every once in a while. So why not just generate the site whenever you make a new blog post? So things like Gatsby, it's really popular in this space. Hugo, Jekyll, Gridsum, which is a Vue-related framework. These all allow you to sort of create static websites in that mold, which is really cool. Another cool trend is headless CMSs. A CMS is like WordPress. If you ever use WordPress, WordPress creates this nice website for you, but also has this nice user panel on the back end. That's the CMS, the content management system. A headless CMS is like WordPress, but takes out that front place. It doesn't give you the website. It just gives you the back end that manages your data, and instead makes your data available to you via an API. Okay. The beauty of this is that for a lot of basic projects, again, like think like blogs, whatnot, you don't have to build your own backend. You can just use a headless CMS. So there are hosted solutions like Butter CMS. What am I thinking of? Butter CMS, Contentful, Graph CMS, and then there's like solutions where they're open source and you host them yourself, like Strapi, Strapi and Hasura. And the idea behind these things is that you don't have to code out the API. You just design what your data looks like, and it just spins up an API you can use for your website, and then you just focus on building the front end. And then even WordPress can be used as a headless CMS now, okay, which is pretty cool. So that's a very useful technology, especially if you're going to go into freelance, because then you can build more robust websites for your clients, provide them a user interface. And actually, maybe I'll mention Netlify CMS, because Netlify CMS kind of works with the static site generators. It helps build a backend for these. So then you can build, a client wants a blog, you can build them a Gatsby blog, which is pretty easy, but then hook up Netlify CMS so they can easily update it, which is really cool. There's so much more. I haven't talked at all about like DevOps and continuous deployment and Docker and all that stuff, but I think these videos are generally geared towards people who are just starting out. And if you're just starting out, this gives you plenty of information to know where to start. Honestly, best place to start. Okay. Let's see here. Let me make it one more slide. New slide. Where to start? Go learn your basics: HTML, CSS, and JavaScript. Head over to dash.generalassembly.ly, and there's a free like 5-course thing where you can really get a pretty nice grip on the basics of HTML, CSS, and JavaScript. And if you're going to do a boot camp, I highly recommend General Assembly, not just because I work there and as an instructor, but I really do. I was a student as well, and I'm very happy with my experience with them and the way the structure of the teaching and the structure of the program. So I highly recommend it. Okay, and then also I have my website, devnursery.com, where you can find free videos to learn a lot of these languages, a lot of these frameworks. So you have the ability to learn. But I'll leave it at that. My name is Alex Merced. Have a great day and enjoy.